Determine whether the following series converges or diverges. The sum from 1 to infinity, n raised to the root 2, e raised to the n plus 3, 2 raised to the n. And so, when you have multiple terms like this, and they're all multiplied, you should think the ratio test. We're going to divide successive terms, a sub n plus 1 divided by a sub n, where we create to get to the heart of the matter quickly, we create a fraction for each of these terms, replacing the n's by n plus 1s, and putting them where they are in the original series. In the gap spaces, we put the term from the original series that corresponds. So below the n plus 1 to the root 2, we have n to the root 2. Above the e to the n plus 4, we have e to the n plus 3. Above the 2 to the n plus 1, we have 2 to the n. And we just need to see what happens as n gets large on each of these individually. And so with that, we need to decompose the last two fractions. We make n plus 4 the exponent to be basically n plus 3 plus a 1. We have e to the n plus 3 plus 1, and we make it e to the n plus 3 times e to the 1, so that we can cancel with the e to the n plus 3 in the numerator. Same kind of thing with the 2 to the n. So what survives is an e in the denominator, a 2 in the denominator. In the first term, ultimately you have, I know root 2 is a strange exponent, but ultimately you have some n. Who cares about plus 1 as we get big, basically? And so it's basically n to the root 2 over n to the root 2. So it's just going to go to 1. So what's left over then is 1 over e times 2, or 2e. The ratio test cares about the size of this. When this is less than 1, it converges. When this is more than 1, it diverges. And e being almost 3, this is definitely less than 1. So therefore we can respond that the original series will converge by the ratio test.